The topics that I'd like to cover start off really with wind. Wind is a very good example of, in the sustainability area, what's happened over the last 30 years in terms of how the commercialization has gone. So talk a little bit about the experience there. And then also the present environment for commercialization and what needs to change to really allow the U.S. to have the full benefit of the technology that we develop here. Then I'll get into a little bit of an overview on what we're doing now, which is Ecomerit. The renewable energy industry really came out of the energy crunch of the 1970s. And it had a very strong start in the early 80s, but there was discontinuity in energy policy, and by the mid-80s, the support for these renewable technologies was taken away, and it wiped out most of the industries. We were able to survive and win because we had a slightly different approach where we wanted to be a power producer, and we wound up owning bits and pieces of projects that would put together, and it allowed us to get through that very tough period. And what's interesting is that whereas the U.S. industry effectively collapsed during that period of the 80s and 90s, Europe picked up the pieces and implemented policies that created huge markets for these technologies. And so they, to a great extent, were able to reap the benefits of the work that the DOE and American industry helped to launch. And you can see that on-again, off-again policy in the graph on the right, where prior to that time period, from the 1980s until the early 90s, these industries were almost non-existent. Then they start to pick up a little bit, and in 2000, the support was pulled. It was extended for 2 years. It was pulled again. It was extended for another 2 years, and that's been essentially the way our energy lawmakers have conducted this business. And it's in a way akin to using the renewable energy industry as a trading chip to get other things that are needed or wanted by the bigger voices in the energy picture in Washington. So I think that until we get a consistent policy in place, it's going to be a struggle for American commercialization of technologies. We're very good at developing the technologies, but creating the market to really be able to deploy these technologies is a challenge. So the experience that I had was starting off with Zond, and we managed to survive into the early 90s, and at that point, we'd just seen the Gulf War. The DOE created some support again for renewables, and we applied with some ideas on technologies in wind that we wanted to move forward with. We got that support, created 3 generations of turbines, and still the financial markets in the U.S. weren't really behind renewables. So in order to get capitalized to be able to really take Zond to the next level, I wound up selling a piece of it to Enron, and by 2000 they bought out the balance of the company. And actually it wasn't that they contributed capital to the business, but we were able to capitalize on their name. And at that time, back during that period, their name was quite good. So that allowed us to really bring the company up to the point where by 2000 it was the largest developer of wind projects and the second largest manufacturer of wind turbines. And then when they got into trouble, GE picked up the pieces in 2002. And with the machine that you see at the bottom, which we'd produced about 800 of, GE has gone ahead and they've produced about 20,000 of that particular turbine. In around 2001, we came up with an idea for how you can really scale up turbines to a much larger size. And the reason you want to do that is that as size goes up, your cost of energy comes down, but it hits kind of the bottom of that cost benefit range around 1.5 megawatts. And we had some ideas on how to do a drivetrain that would allow us to go to a much larger scale. And that's the image on the right. You can see the benefit with these images. The machine on the bottom there is a conventional 2.5 megawatt turbine. And with the reconfiguring of the drivetrain, we were able to create the same 2.5 megawatt size machine that's shown on the top. So there was a number of other things that went along with that, but that was a basic concept. And it was quite a bold move to really think that you could get into a fairly mature market with a new technology. The market at that point was around, I don't know, $10, $12 billion. With a new technology, well, it's in the energy business, it's not the machinery that's the product. The product is cheaper electrons. And if you can bring down the cost of energy, which we were able to demonstrate we could do with this design, we brought it down by about 18%, you will get a market. But in commercializing, there's other pieces that you have to bring into play. I think it's useful just to see the timeline on this because it was a fairly accelerated pace considering that this is big capital equipment and virtually nothing in the design of the machine is something that came out of a catalog. This was a new design generator. We introduced a permanent magnet generator, new controls, designed our own blades, pretty much the whole thing. And then for a startup company to be able to put that into production was a Herculean task with no supply chains having to get all that started. Anyway, we were able to do that. And we wound up testing the machine in early 2005. And still in the U.S., the capital markets were pretty weak on renewable energy. So we wound up going to the London Stock Exchange and did an IPO there. And we were able to start a production. Went into an abandoned facility in Iowa, 300,000-foot facility, started manufacturing and produced 500 turbines. And as was mentioned earlier, United Technologies bought that company in December of last year. The pace of this activity, I think, is a very key thing in the way we think about commercialization of sustainability related technologies today. We've got to move this stuff very, very quickly. And typically in commercializing this sort of activity, it's more than just manufacturing. In the case of Clipper, it was also being able to essentially create our own projects. We went around the country and back in 2000, 2002, 2003, there were a huge number of very windy sites that were available. No one was interested in wind at that point in the US. And we were able to build a very substantial portfolio. Also had to put together the ability to install and operate the machines. And then at the same time, if you're really going to carve out a leadership position with the technology, you better be thinking about the next generation machine. And we really saw the next generation as being offshore deployment. So we've advanced with the design of a 10 megawatt offshore turbine. It's about 450 tons on top of the tower. It's a 150-meter rotor and a 10 megawatt rating. That machine, in its lifetime, will produce the energy equivalent of the largest super tankers today, which is about 2 million barrels. Now, what keeps me moving is the urgency for getting this done. And number one, we're way beyond the sustainable yield of the planet by 50%, according to some indications. Water tables are falling, glaciers are retreating, agriculture is right on the fringe now. We have a bad crop this year. It's really going to cause great problems on prices, and we're seeing hunger increasing from 800 million to about 1 billion now. It's on the rise. We're importing 2/3 of our petroleum, and we're in a phase where oil is peaking. So how do you go from 90 million barrels a day to the 120 million barrels that is going to be needed 10, 15 years from now? Climate change is intensifying. We're being told that to really stabilize climate at a 2-degree rise, we have to decarbonize by 80% by 2020. I mean, these are pretty formidable kind of things to face. And now, this year, we crossed 7 billion people on the planet. We're adding another 1.5 million people every day. And so it's no surprise that the number of failing states around the planet have doubled in the last 5-6 years. This is what, I hate to take you through this because you all know this material, but it's why we've come up with a different model than the Zond Clipper approach. And it's one of going to a development lab for sustainability-related technologies. And with the lab, our aim is to take it from the concept to essentially product certification. It's a different model than the earlier one where we take it all the way into commercialization, but the thing that's different today is that you have major corporations around the planet that want to get into this kind of area, but they haven't had their R&D focused on it, and there's just not a whole lot of ways they can do it. So I believe that with a development lab that can move forward 5 or 6 or a dozen technologies, there will be a way to hit commercialization with those, and that's kind of the basic idea of this lab. Right now, we're concentrating in five areas: marine energy, wave and ocean currents, bulk energy storage, production of potable water, green building systems, and combined heat and power. We believe that these technologies have the potential of being in certification in kind of a 4 or 5 year time frame. No doubt some of them will take 5 to 10 years, but that time frame is something that we've been able to achieve earlier. And so examples of this. This is wave energy. This machine, 4.5 megawatts, will supply about 1,500 homes. If you deploy 2 rows of these machines over a 20-mile stretch, you've got the equivalent power of a nuclear plant. And we've got a variant of this machine that produces fresh water. The wave energy resource is very large. You can see the circled areas on the map below. Mostly it's western shores, and a lot of those western shores have very dry climates, so it's the combination of being able to produce both power and water makes it an interesting area to engage in. The second area is ocean currents. And in ocean currents, people generally think about tidal currents. What we're looking at are these steady ocean currents that are the big gyres, driven by the Coriolis effect. And there are some very large market areas that have these currents fairly close to shore. These are some of the areas that we've identified. We're in particular interested in the coast of Florida, where you go out 15 miles, you're into a current with a velocity of about 1.6, 1.7 meters per second. And the merits of this technology is that you have a steady flow, so you have a very high capacity factor. So you're essentially delivering base load energy at a pretty competitive price. To be able to commercialize this, you have to do all of the other things of really understanding the velocities and the profiles of the current that you're going into, and the environmental studies and grid connections and all that sort of thing. So all of that is part of what we do in parallel to keep within that 4 or 5 year time frame. So that is a significant market for this product. This is the Aquinas Turbine, and you're now diving down into the depths about 50 meters below the surface. And those are 2.5 megawatt machines, very high energy density, and we believe that it can be something that we can bring to commercial use in about 4 to 5 years. So, in summary, I think there's elements of the market today that are very positive for commercializing. There's a huge entrepreneurial interest around the globe on sustainability technologies. Like I mentioned, big companies are interested in this, so there's a ready ability to absorb the technologies and take them into commercialization. And we have really excellent infrastructure in place now with the DOE labs supporting these efforts. Testing facilities that 5-10 years ago just weren't available. Today you have both in Europe and here. And a very key thing is the certification. To really get to be a commercial product, you do have to go through a fairly rigorous certification process. And we have a lot of engineering and science that has gone through decades of this sort of thing. So there's some very deeply steeped technical expertise available. Europe and the Asian governments are strongly supporting the move to renewables. China now, which just started 4 or 5 years ago in wind power, is now 50% of the production on the planet. And my final point is that sustainability technologies are going to struggle in the U.S. unless we can get our government to really be clear on the real costs of energy. If we know what the costs of energy are, not just from the direct costs, but the health aspects, climate change, the cost of the military, until you can get that out into the open, I don't think our ability to implement renewables is going to be what it really could be and should be, and that is an urgent change. Thank you.